Alright, let's bust out this review packet. Alright, question 1. We are eliminating the parameter for everything. So we start off with x equaling sine squared. I don't want to deal with that one at all. That does not sound like fun. No, that's not bad, right? We got sine and cosine, so we're pretty much always going to be doing the thing where we isolate the trig value and then square it, and then we can plug it into sine squared plus cosine squared equals 1. So doing that, we have sine squared is x plus cosine squared is going to be y squared over 4 equals 1. And if I just do a little bit of fancy rearranging on this, so we'll end up with, y squared equals, I can do math, 1 minus x, and then I'm going to multiply all that by 4, right? So let's see if we kind of further rearrange that a little bit. I'm going to factor a negative out of that. That's going to give me a negative 4, and then I can flip-flop those. And, okay, this is our, y squared equals 4px. This is a parabola. Recognize that 1 squared and 1's not. That's how we know it's a parabola. Okay, so that was A. B. X equals e to the negative, whatever that says, y equals e to the 3t. So I'm thinking we're going to try to get something to equal e to the t, and that's what we'll substitute in. So I'm not going to actually solve for t equals. I'm just going to try to do that. So let's focus on this guy. That negative drops this to the bottom. If I multiply it over and divide, I'll get e to the t equals 1 over x. And I can substitute that into this one now. So I'll get y equals, let's see, this is really e to the t to the third, power multiply. So I'm going to have 1 over x to the third when I do the substitution, which gives me 1 over x to the third. X is in the denominator, so this is a rational function. Boom. Yay. Math. So much fun. Ooh, a little natural log going on here. That's fancy. Y equals 2t squared. Okay. Well, I don't really want to deal with trying to solve for t over here because I'd end up with a plus or minus square root in order to do that. So I think we'll focus on this, and maybe we'll try just switching form. So this is really e to the x equals 2t. So t is going to equal e to the x over 2, and now I can substitute that in over here. So I'll get y equals 2 parentheses e to the x over 2 squared. And if I just simplify this a little bit, I'll end up with 1/2 e to the 2x. X is in the exponent, so this is an exponential function. And there we go, done. If I look at part D, we have x equals 3t, y equals t plus 7. This one's going to be so hard, I can just tell. Take that, plug it in, we get y equals x over 3 plus 7, all right? And this is linear function because we have mx plus b. Whew. Hardest one, don't you think? I don't feel like I didn't have those labeled right with the A, B, C, D's, because this one's E, and I feel like I already did an E. I have no idea now. T squared plus 1, y equals t squared minus 1. Cool, so I'm going to solve for t squared because that's in both of them. So I'll just do it over here. I'll get t squared equals x minus 1, and I'm going to just substitute that in over here. Y equals x minus 1 minus 1. So that's y equals x minus 2, which, again, is linear. X to the first. All right, last one. I think we'll just start with a nice clean slate. Here we got f, x equals 2 cosecant t plus 1, y equals 3 cotan t minus 5. So whenever we have these trig values, our thought is that we're doing something with the Pythagorean triples. So I'm going to isolate each one of the trig functions by just subtracting and adding and dividing and all of that fun stuff. And then I'm going to square everything. That's just so that it will fit into the pattern. So let's see, which one are we using? We're going to use cotan squared t plus 1 equals cosecant squared t. So plug these things in. I'm going to get y plus 5 squared over 9 plus 1 equals x minus 1 squared over 4. And I'm just going to get the 1 by itself. So I'm going to subtract this to the other side, so I'll have x minus 1 squared over 4 minus y plus 5 squared over 9. That equals the 1. I just flipped my inequality. Minus with 2 of them squared, that's a hyperbola. Hyperbola. There we go. Question 1, done. Only 8,000 more to go. Dirty, dirty whiteboard. Do you see that? Yeah. Woo. 2, find a set of parametric equations that trace a circle with a radius of 4 and a center of negative 1, 2. All right, so one of the things that I like to do when we have this setup here, where we have this negative 1, 2, radius of 4, is I like to just quickly figure out where all of the quadrantal angled points would line up. So for radius of 4, this is going to be at 3, 2. This one's going to be at negative 1, 6. This one will be at negative 1, negative 2. 2 minus 4, negative 2. Math, it's tricky sometimes. This one's going to be negative 5, 2. So that's just going to help me figure things out when they tell me where I'm starting. So first one says, A, we're starting at 3, 2. So that's this one. So I'm going to abbreviate it by saying that I'm starting there, and I'm going clockwise. So remember, what we like to do for this circular type is we always look at where we're starting. We're starting at a maximum x value, so x is going to be positive cosine. The y value will be a sine, and we're going down, so it's going to be negative sine. So for this one, we're going to have x equals 4, the radius, cosine. They didn't give us a speed, and they told us the center is at negative 1. For sine, negative 4 sine, and then plus 2. So that is A. B, they say we're starting at negative 1, 6, so that's that top point, and we are going counterclockwise, which is that way right there. So when I'm doing my little xy's, trying to figure out what's what, this is starting at a maximum y value, so y is going to be the cosine. X is going backwards, so it will be negative sine. So I will have, let's just write it right here, x equals negative 4 sine t minus 1, y equals positive 4 cosine t plus 2. So notice what the radius is, and the center points aren't changing here because those remain constant. It's the positives and negatives and the sine and cosine that are switching as we move ourselves around. Negative 5, 2, going counterclockwise. So that's here, going backwards. So starting here, that's x value, that's negative. So x is going to be a negative cosine. Y is going down, so it will be a negative sine. So x is going to be negative 4 cosine t minus 1, and y will be negative 4 sine t plus 2. Last but not least, for this one, we're starting at negative 1, negative 2. That's at the bottom, going clockwise. So here, going that way. So I'm starting at a minimum y value. So y will be negative cosine, and x is going backwards, so it will be negative sine. So x equals negative 4 sine t minus 1, and y equals negative 4 cosine t plus 2. Woo! There we go. Question 2. Donezo. Question 3, we're finding a line that goes through a set of points, 1, 4, and negative 5, negative 8. So it starts here and goes that way. That's important. And it's a line. All right, so I'm going to first find the change in x by doing the ending point minus the beginning point. So negative 5 minus 1, so that's negative 6. Change in y is going to be negative 8 minus 4, so that's negative 12. They don't tell me anything about the change in time, so I'm going to assume that it's 1. And now I just use those equations that we learned. So delta x over delta t, so negative 6t plus the starting point, plus 1. Y is going to be negative 12t over 1 plus 4. Okay, and then it's a line, so it goes on forever. And there we go. Now, next one is the same exact scenario, okay? So this is number 4. We have the same setup. The delta x is going to be negative 6. Delta y is going to be negative 12. But this time they tell us that the change in time has to be 3. We're going from 0 to t equals 3, and it's a line segment. So when I write my equations, I'm now doing negative 6 over 3t plus 1. Y is going to be negative 12 over 3t plus 4. And this is going to go from 0 less than or equal to, so we have endpoints on our line, up to 3. And then you could simplify this if you really wanted to write it as the negative 2t plus 1, and then this is negative 4t plus 4 with that same interval. So that would probably be my final answer. Ta-da! Woo! Yay, using the black marker too much. Let's switch. You want to go purple? Let's go purple. Oh, yay, people playing tag. So much fun. All right, so we're playing tag. All right. So we got first person is going to be moving 2 feet west, 3 feet north. So west is a negative x direction, and north is a positive y direction, and their starting point was 1, negative 4. So that's the first person. The second person, I'll just put little thingies like that. Second person's equations are going to start at 10, 13. They're moving 5 feet west and 2 feet south. So I'm going to have negative 5t and negative 2t, and then what is the starting one? I already forgot, 10 and 13. All right, so we want to know whether or not they're going to actually tag each other, whoever's it. So I always like to set the x values equal to each other for this. So I'm going to do negative 2t plus 1 equals negative 5t plus 10. So doing all of this fancy math, I'm going to end up with 3t equals 9, so t is going to equal 3. So the x values are equal at 3. What I need to do next is compare the two y values. Okay, so I'm going to do the y value of the first person at 3, and I want to know, does that equal the y value of the second person at 3? So up here, that's going to give me 3 times 3 minus 4, and I want to know, does that equal negative 2 times 3 plus 13? So let's see, math is tricky. 9 minus 4, that's 5. I want to know, does that equal negative 6 plus 13? I'm pretty sure that's 7. Those are not equal, so no, they didn't tag the person. So sad. Ooh, we get to use the fancy board. It's very dirty. Holy cow. Let's clean that off. Just also drew all over my thumb with that. That's disgusting. All right. Let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, something. I don't know. I'm all off. All right. Watching the uncut. Sorry. All right, let's try that again. This is looking much nicer. Don't you agree? That last one was awful. All right, so we got something going on here, 0, 3. It goes somewhere over like here-ish, and then it goes to here, and then it goes to here. All right, so we got something that's going like this. And I don't really care about those other parts. What we want to know is in this equation that we have here, x equals 2 minus absolute value t. Oh yeah, you probably hated these questions when we did it in the first day. We want to find the values of t that put us in the fourth quadrant. So we care about what's going on right here all the way until right here. So let's think about this for a second. What do we know about this point right here? Okay, so at this point right there, we are pretty positive that the x value is 0, right? So if I said x equal to 0, and then I just solve this equation, I'm going to get that t is either going to be positive or negative 2. So what I need to do is figure out which one is which. So I'm going to plug in y into positive 2 and y into negative 2. So I'm going to end up with a positive 1 and down here a negative 3. So it makes more sense that it's t equals negative 2. So I can say this is going to be t equals negative 2 because I know that this is definitely below the axis. So this is negative 2. Now let's figure out what's happening right here. At this point, we know y equals 0. So I'm going to set y equal to 0, and I'm going to get t equals 1. I don't really need to do anything else. If you really want to, we can see what is x at that value, and it is going to be 1, which lines up. So I know that this is a t value of 1. So this thing is in quadrant 4 from -2, not equal, to 1. The reason it's not equal is on the edge. It's not actually in a quadrant. So we're basically just using our knowledge that x, y, and t are all connected, and if I know the x value at this point has to be 0, I can find t, and if I know the y value has to be 0 at that point, I can find t that way. Whew. This is exhausting. Is this tiring for you? Is it just me? Oh, a deer hunter shoots an arrow, initial height 6 feet, blah, 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 blah. All right, so we can get the equations going on for this. It's going to be 144 cosine 5.5 degrees. Make sure your calculator's in degree mode. T, y equals -16 t squared plus 144 sine 5.5 degrees. T plus 6, when we have t is greater than or equal to 0. So those are the equations. We want to figure out the max height. All right, so max height, that's pretty straightforward. We're going to do t equals -b over 2a. So that's going to be a -144 sine 5.5 all over a -32. When we type that all into the fancy calculator, I'm going to get 0.4313. I'm going to store that, and I'm going to plug it into the y equation for t. When I do that, I get 8.98 feet. So that's its max height. Doesn't really travel very high, which makes sense because the angle's very minimal. Oh no, a deer is standing 30 feet away from the archer, 4 feet high. Will the arrow strike the deer? Oh no. 300 feet away, that's in the x direction, so I'm going to do 300 equals 144 cosine 5.5t. I'm going to divide the 144 cosine 5.5 to the other side. I'll get t is equal to approximately 2.09. I'm going to again store that and plug it in to the y equation, and I get -35.2 feet, which means that this thing hit the ground well before the deer. I was going to try to draw a deer, and like this is me drawing antlers on the deer. That's the best you're going to get. So it is safe. Okay, definitely did not hit. Let's erase all this junk. Give myself some space for the next part. All right, will it hit the ground? All right, so that's when y equals 0. I need to know what a is, -16. B is 144 sine 5.5. C is going to be 6. I'm going to do the quadratic formula, but remember, we should work by just writing it out, and then we use the calculator to do the rest of it for us. So I'm going to get that t equals 1.18, so that's how long it's in the air for. And if I want to know how far it actually traveled, I just use the stored value in the x equation, and I got 169.18 feet is how far it traveled in 1.18 seconds. There you go. Question 7. Question 8, will these things collide? So you know me, I'm a big fan of just setting x's equal to each other. So let's just do that. So I get 20 cosine 40t, calculators in degrees, equals 30 minus 25 cosine 45t. Again, it's important t is outside of the parentheses there. So I'm going to add this to the other side. So I'll get that 20 cosine 40 plus the 25 cosine 45. I'm just going to choose to factor out t all in one step. And then I just take this whole thing and I divide it over. So I'm going to end up with t equaling 30 divided by, I would use big parentheses in your calculator, all of that junk. 20 blah, 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 blah. And you get 0.909. And I'm just going to store that value real quick. And then I'm going to plug that into the y equation for each one. And I just want to compare what happens. Okay, so I'm plugging in the 0.909 to both of them. I get 0.4632 for that one and 5.84. So that's a big old no, they don't collide. All right, cruising. All right, so this is just a connection to vectors. It doesn't show up super often, but we have a plane leaving bearing of north 50 east. All right, so I'm going to draw that. Here's north 50 east. I'm a big fan of never actually writing in the bearing. So I'm going to do that, and it is traveling at a speed of 500 miles per hour. Same time, second plane, which is 600 miles away. Miles, words are hard. Okay, it's chilling over here. It's flying at a bearing of 38 west. Okay, so that's going this way. And we have a couple options here. I'm going to put the reference angle 52 there. You could also do the whatever 128, whatever you want. It is traveling at 450. So we want to write a set of parametric equations for these, and we do that by taking what the vector would be. So the vector would have been 500 cosine 40 and 500 sine 40 for each one of these ones. And then we just multiply that by t, and that allows us to take this velocity that we're getting and expand it over time. For the next equation, it's the same idea, but I'm going to do something a little tricky. I've set this as 0, 0 based on these equations, so I need to start off with 600, and then I'm going to use the 52 by subtracting here. So rather than doing cosine of 128, which would be negative, I'm just going to do a negative 450 cosine of 52t. And for y, I don't actually need to worry about it because sine of 52 and sine of 128 are going to be the same exact value. So I don't need the negative here. I can also see that this is happening, right? Negative in the x direction, positive in the y direction when I'm looking at this particular point, if you don't really believe me. So we have that. Now we want to know, is there a danger of these things colliding? So I'm just going to set the two x values equal to each other. So that's, 500 cosine 40. It's like a lot of work to keep writing this over and over and over and over and over. Don't you agree? I'm going to add this stuff over and then divide the whole thing. So I end up getting that t is equal to 600 divided by 500 cosine 40 plus 450 cosine 52. And I'm very carefully typing that into the calculator, making sure I put my parentheses in the right spot. I got t is approximately 0.91. I'm going to store that. I'm going to put it into the first y equation. And I got 292.1, put it into the second y equation, and I got 322.3. So no, these planes are nowhere near colliding with each other because their y values are off by, I don't know, that's a lot, right? 30-something miles, so they're not really near each other. I think this is the last one. So exciting. Don't have to sit on the ground anymore. Okay. Ferris wheel, 30 feet, 1 revolution every 10 seconds. Okay. And it's 6 feet above the ground. So the center point is going to be 0 in the x direction, 36. 30 up for the radius, 6 above the ground. Its speed, 1 revolution every 10 seconds, so it's 2 pi radians every 10 seconds, so it's pi over 5 radians per second. Write a parametric equations, describing the motion, starts at 3 o'clock, rotating clockwise. Okay, so 3 o'clock is right here, clockwise is going down. So, like to do this little thing, start at this point. This is a positive x value, so it's going to be the starting point, positive cosine. Y is going down, so it's going to be negative sine. So this equation is going to be x equals 30 for the radius, cosine. Y is going to be negative 30 sine. The speed, pi over 5. T inside the parentheses, plus the 36 to give us our center. So there we go, that's the first part. Now the only thing we're basically changing here is which one's sine and which one's cosine and which one's positive and negative and all that fun stuff. If we start at 6 o'clock going clockwise, alright, so let's look at this. This is going to be starting at a negative y value, so y is going to be negative cosine, and we're going in a negative x direction to start off with, so that will be negative x. So a negative sine, so that's negative 30 sine. This one's going to be negative 30 cosine, and then everything else stays the same. Pi over 5t, pi over 5t, plus 36. Done. That's the worst C ever. There we go. C. We're starting at 12 o'clock, so that's right up at the top, and we're going counterclockwise, so that's that way. So this is starting at a maximum y value. Y will be positive cosine. We're going in a negative x direction, so x will be negative sine. So negative 30 sine. Y is going to be positive 30 cosine, and everything else about this stays the same. I'm getting tired of writing the same thing over and over. Last but not least, starting at 9 o'clock, fun, going counterclockwise. So that's that way. So we are starting at the lowest possible x value. So x is going to be a negative cosine. Y, we're going down, so y will be negative sine. So we'll have x equals negative 30 cosine. Y is going to equal negative 30 sine. And all of that stuff stays the same. Whew. And there you have it. That is the review packet. Woo! That was so much fun.